Okay, so here we're going to start looking at a hyperbola. So here we have x squared over 4 minus y squared over 9 equals 1. Now, since the x comes first, we know this will be a horizontal hyperbola. So we know it's of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. So notice we're not subtracting anything from x or y, so that means h and k both equal 0, that this is centered at the origin. Now notice that underneath, just like an ellipse, we're going to take the square root of the number underneath to get a. So a will be 2 and b will be 3, since the square root of 4 is 2, square root of 9 is 3. Now, to get c, we always use the formula for a hyperbola. C squared equals a squared plus b squared, just like the Pythagorean theorem. So here c squared equals 4 plus 9. C squared equals 13, so c is equal to the square root of 13. Okay, so we know we're centered at the origin. And we know to get our vertices, we need to go, since this is horizontal, left and right by a. So right by 2 and left by 2. And then we need to go up and down by 3, since that's our b and that's our other direction. Now we're going to use those 4 points we just drew to do our guide rectangle. Okay, now since we're horizontal, those 2 horizontal points we drew are our vertices, so we can see that's at 2, 0 and negative 2, 0. And the endpoints of our conjugate axes are our vertical ones, so 0, 3, and 0, negative 3. Now our foci, since they're going to be they'll always be along our transverse axis where our vertices are. So we're going to start from our center and we're going to go left and right by c. Now the square root of 13 would be bigger than 3 and smaller than 4. So we'll plot it between 3 and 4 and between negative 3 and negative 4 along our horizontal axis, since we've got a horizontal ellipse. Now here, this would be at square root of 13, 0 and negative square root of 13, 0, because we went that distance from the origin in the horizontal way. Now, we know that the equations of the asymptotes, we'll know that they're actually just going to be the diagonals of this rectangle. Okay, and here we can then sketch the hyperbola. We're going to take it through our vertices and then just go out and kind of make it so it's getting closer to those asymptotes. Okay, now to write the equations of the asymptotes, we know they look at like y equals b over a x minus h plus k, and y equals negative b over a x minus h plus k. Now, h and k are both 0, and we know b is 3 and a is 2. So we've got y equals 3 halves x minus 0 plus 0. So it's just going to be y equals 3 halves and y equals negative 3 halves. Okay, so there's our first hyperbola. Let's look at another one. Now, the general form looks like the general form of that we've seen before. Here, since we don't have just x terms and y terms, we're not going to have to complete the square, but we do want to first put the 50 over on the other side, so we're going to write it as 2x squared minus 25y squared equals 50. And then the equation for a hyperbola always just has a 1 on the right hand side, so we're going to divide everything by 50. And if we simplify this, we'll get our standard form, which I'm going to write over here. We'll have x squared over 25 minus y squared over 2 equals 1. Okay, so again, we have a horizontal one here because the x is first. Our a here will be 5. Our b will be the square root of 2. To find c, we'll say c squared equals 25 plus 2. So c squared equals 27. So c will be the square root of 27. Now again, this one's centered at the origin. Okay, and we're going to go left and right by 5 and negative 5 to get our vertices. So 5, 0, and negative 5, 0. The endpoints of our conjugate axis, we're going to go up and down by the square root of 2, which is bigger than 1 but less than 2. So that would be at 0 square root of 2 and 0 negative square root of 2. And our foci, we need to go left and right from the center by a square root of 27, which is between 5 and 6. Right? You can always put that into your calculator to get a decimal approximation, but we know 27 is between 25 and 36, which the square root of 25 is 5, and the square root of 36 is 6. So this is at negative square root of 27, 0, and square root of 27, 0. Now again here, our h and our k are 0, so the equations of our asymptotes are going to be y equals b over a x and y equals negative b over a times x. So here we get y equals square root of 2 over 5x and y equals negative square root of 2 over 5x. So I'm going to draw my guide rectangle. And then I'm going to draw the diagonals. And then we're going to take our vertices. And we're going to draw the hyperbola out toward those asymptotes. Okay, so there we had two hyperbolas, both of which were centered at the origin.